you remember the exact keyword distributed system,
Yeah, yeah,
distributed system is one of the keyword. Like
yeah,
if
yeah.
you see
There.
the first kind of sentence for answering this type of thing. So we are discussing here how to answer something in short way. So like Leslie Lamport proposed widely used algorithms and tools to develop applications in distributed computing. This kind of answer could be enough. Like Leslie Lamport have done something in time sharing and multitasking in distributed system, and it proposed most used research work in computer science, one of the most used research work. Like he imposed ideas on distributed computing, anything like for the computer communication with message passing. He developed algorithms for real distributed system. He improved time sharing, multitasking of distributed system. So you can write in simple, that's enough.
I wrote
Like in
down, yeah, I wrote down that he developed algorithms which improved in increased quality like correctness, reliability.
yes, yes. So, yes, any one point is enough for evaluating. It means that you had studied something about Leslie Lamport in that slide and cloud computing.
Yes, got it,
So,
got it.
it explains that you have studied and have some idea, and you can discuss something about him in 20 words
Yep.
and cloud computing. So, similarly, in the second, what is main contribution? So, highlighted in the research paper. So you can see he did actually shifting of distributed computing and cloud computing era too much. So time sharing is one of the most basic thing that he devised. So it shifted what distributed and large scale and cloud computing like thing. So what are the benefits? Who are the benefits stakeholders? Like engineers, theoretical computer science scientist, or programmer. So in the third point, we can see that these are the stakeholders, engineers, programmers, and theoretical computer scientists have got actually benefited from his design and implementation of the system. So you can write about that. Similarly, in the second point, benefit of for research computing in the parallel or high performance computing. So high performance computing, concurrent algorithms, software reliability, all these fields are being in the benefit. So you can just write the keyword of those domains and stakeholders. That is enough for answering that question. It has improved industries like Bing, like even Google and other, like Facebook, for distributed and cloud computing. That is, I think, but you have to specific to some keyword like distributed system, cloud computing, large scale distributed systems, parallel processing, high performance computing, concurrent algorithm. That is enough. Next,
Sir,
if we
sir, in question number two,
yes, yes,
sir, it's written in the slide, page number 13, that he devised important algorithms and developed formal modeling and verification protocols that improve the quality of real distributed system.
yes, yes,
So
yes,
these contributions have resulted. So I have written these contributions in answer two. So will they be
yes, yes,
correct?
yes, yes, sure, sure, sure. Means because that is too much detailed way of writing formal verification modeling. So if you remember all these type of keywords, that is even much better. So I'm just explaining the minimal way to answer that question. Means how less you remember and how better you can write. So these are the four ways to answer, and there could be even more than four ways, any number of ways. So if you write simply about something about Leslie Lamport and his contribution, main contribution, that is significant enough. Mm.
Okay, sir.
So similarly, we'll see how we can answer the third question. So this is something tricky or some conceptual, and but it's very easy. Suppose your organization has significant computing infrastructure, but is still undergoing huge spikes for user or require cloud bursting. Which type of cloud computing model is better in this condition and why. So you just write hybrid cloud as the first two words, and you write whatever benefits of that hybrid cloud. That would be enough. For example, extension of capacity and capability of cloud services for aggregation and integration, so with another cloud service. So this is advantage. And again, hybrid cloud has feature of connect and maintain and dedicated service, both private and public resources. Hybrid cloud can interconnect private cloud to the business application provided by the public cloud provider. So fifth one we can see. So fourth one we can see, for cloud like public cloud could meet some temporary demand where high usage is required. So the private cloud cannot provide. So sudden increase could be provided. So in the fifth answer, so it says that cloud busting for fulfilling demand when sudden increase of high capacity is required in the application deployment in the private cloud or data center, which is called busting. So at this condition, it is important. Similarly, you can answer like during spike in the processing demand requirement private cloud infrastructure. Thus, you need to manage workload, and then you have to do shifting from private cloud to the public cloud. And this hybrid cloud is also like extra payment, but you pay only for the amount of the usage that you do. Next, another conceptual type of question. Suppose your organization has significant computing infrastructure. Which type of cloud computing is better? It is simple private cloud. We establish our own cloud computing m- model at our own organization that would have intelligent to do decision making and resource management. Then you can also write like it improves business, also raise security issues, like you can maintain your data center in the separate building of your organization, and that separate building could be protected by some security guard. So privacy of your organization will stay private and it will stay security, and you have to address some of the security issues. Then private cloud is basically capital intensive, but once you purchase some hardware, environmental or security like things, so it will become permanent asset to your organization. This is also one of the good point. And next, you can write that operational expense like capital expenditure are renewable, so you can have better infrastructure for long duration for your organization. So you can write about that as well. Next, you can write like you can manage, pay, build and expertised persons. So you can have that private cloud. Next, like public cloud is some of the time free and offered for the pay as per usage model. Next, benefit for that public cloud, so you just need to write some keywords like security, storage are better in cloud, public cloud. There is big companies like Google, Amazon, Microsoft. These all provide huge infrastructure and data centers for an organization to have a public cloud. So you can purchase some lease or some connection for maintaining the public cloud. Next, like we had seen one numerical example earlier as well in the class. Similar to this, suppose you want to transfer 1 terabyte data from X to Y location in 10 kilometers apart. Assume there is average bandwidth found to be 1000 megabits per second in between X to Y. So here 10 kilometers have very less significance, and the most significant part is calculation. So in your opinion, which is better, physical medium or some network medium? What is physical medium? Using storage devices for transferring, copy pasting something in the storage device and then transferring it to the another location. Next, you can directly transfer that whole stored device from one place to another physically, but you also prefer to use network, means wired or LAN based transferring with something, but you have to do first calculation. So how you do calculation? So first, like for data intensive application, data placement and transportation across boundaries of the cloud may be complicated. So you do calculation for data transfer cost. How you do data transfer cost? You first have to do, assume like 1 terabyte is the size you have to transfer. Then you have 1000 megabits per second as average speed. So you calculate the whole thing like it would take 1 cross 10 to the power 12 bytes divided by 1000, that speed, into 10 to the power 6 bits per second. Now you have to convert bytes into bits. So you multiply by 8. So 8 cross 10 to the power 12 and divided by 10 to the power 9, and this will become 8 into 10 to the power 3 seconds. So in this much second you have to transfer, and when we convert it to the hours, it will be 2.2 plus hours. So this much amount of time could be affordable and manageable with network transfer. So you prefer to do network transfer instead of relocating some storage device from one place to another. Next, in the opposite, we have a large size of data transfer like 1000 or 100 terabytes. So for the 100 terabytes, suppose you have to transfer 100 terabytes from X location to Y location, which is 10 kilometers apart. Now you have a bandwidth which is lesser than earlier one. You have a bandwidth of 100 megabits per second between X to Y. What is your opinion for transferring this data, whether you want to transfer it in the physical storage device or you want to transfer it with the network with 100 megabits per second speed? So you transfer that with the help of calculation. First you calculate that thing. How you calculate? You put your information like 100 terabytes. So you convert terabytes as 10 to the power 12 bytes. So what is 10 to the power 12 bytes? It is size of 1 terabyte. So 10 to the power 12 bytes is equal to 1 terabyte. And then you put uh, how much speed that you have. You have a speed of 100 into 10 to the power 6 bits per second. So you converted mega as 10 to the power 6. Simple. Tera is like 10 to the power 12. Bits mega is 10 to the power 6. So it is just simple normal creature that you have to understand for tera and mega. What is tera? 10 to the power 12. What is mega? 10 to the power 6. And how you calculate the time required? You just divide the size of the data set that you want to transfer divided by the speed that you have. So size of the data 100 cross 10 to the power 12 bytes. This is size of 100 terabytes divided by 100 cross 10 to the power 6 bits per second. This is speed of your network. How much it will become? 8 into 10 to the power 6 seconds. 8 into 10 to the power 6 seconds. When you convert it into the hours, you have 2.2 cross 10 to the power 3 hours, What does this mean? It is like 2200 hours, means 2200 plus hours you require for transferring. So instead of this, 10 kilometers is very small. You see that 10 kilometers, okay, we should copy paste that thing from one hard disk or one storage device to the another storage device, and then transfer that storage device from X location to Y location. Or instead, if you can afford, you transfer your stored device itself from X location to Y location. That would be even much better. Next, the question is like any four obstacle and opportunities that you in the cloud computing domain. So you simply write any four out of these 10. So what are the 10 obstacles that we had seen? Availability of service, data lock-in, data confidentiality and auditability, data transfer bottleneck, performance unpredictability, scalable storage, bug in large-scale distributed systems, scaling quickly, reputation fade sharing, software licensing. So in this opportunity, you look very clearly that how small opportunities has been written. Can you see only 10 to 20 words? That's it. And this is very standard way of writing. What they have written, only some verb or something preposition. What is verb? Use. Use multi-cloud provider. What is multi-cloud provider? It is jargon or a noun. Multi-cloud provider is a noun. It has been used with one verb, and then to is just a simple preposition to provide. Business continuity. What is business continuity? It is something that is to be explained, and this opportunity haven't explained this business continuity. This is technical jargon again. So there is only two jargons: multi-cloud provider and business continuity. So this is the way you write in very short way. Another example, use elasticity to defend against DOS attack. So DOS attack is not been explained. What is defend? Defend is not explained. Elasticity is not explained. But anyone who is technical person can understand what is elasticity, what is defend, and what is DDoS. DDoS means distributed DOS attack. And what is defend? Means defending some malicious attack. So any technical person could even able to understand this high level of technical jargons. This is the requirement of you to learn how to write. Use elasticity to defend against the distributed DOS attack. That's it. This is just one, two, three, four, five, six, 7 words. 7 words and too much technical. Like data lock-in, it is standardized APIs. That's it. Means standardized APIs is enough to write to defend the data lock-in as an opportunity. And you just write something like compatible software available to enable surge of computing. This is also enough for explaining data lock-in uh, as opportunity for new cloud computing. Like for data confidentiality, VLAN, firewall, deploy encryption, and national international laws, geographical laws, like data transfer bottleneck, what we have seen just now in these two questions. So this is data transfer bottleneck, like FedEx disk. So it is like disk transfer, data backup archival, bandwidth, higher bandwidth switches, routers. So both cases had been explained in these two. High, like in this, high bandwidth and better switches are required for question 6, and better storage devices are required for copy pasting data from one storage device to another storage device and then transferring that second device from X location to Y is explained in question 7. And this is like the data transfer bottleneck. Next, performance and predictability. And performance and predictability, like improved virtual machine requirement, flash memory is required, scheduling of virtual machines are required, and scalable storage is again a obstacle. So you need to invent some of the scalable storage medium or ways. Then bugs related to large scale distributed system programming, like you invent some debugger or that reuses distributed virtual machines. Scaling quickly, like inventing auto scale that relies on machine learning type of thing or data mining type of thing. For cloud computing, snapshot generation, whether it is scalable or not scalable. So reputation fate, like you actually use some of the parameters for analysis of reputation of some services like email or software licensing, like pay for the usage of the licenses or bulk using the sales. So all these things, if you describe it one or two lines, three lines, then the person who is from the technical background of cloud computing could able to understand what you have written and what you want to explain. So these are the 8 questions that we had seen in the midterm exam. Thanks. Next, we have the same way for the final exam. We'll try to do it even much better than this. And all the best for the final exam.